This is the Truss Lab. A truss is a structure that supports a load. In this case, the load is this tuna fish can. You could use any small weight, maybe about 2 newtons or so. The string goes up to a paper clip, draped over the meter stick. Everything's held in place with a binder clip. The binder clip is attached to the meter stick, which is pivoting at the other end. I can raise this up and down and we can see how it moves freely. The meter stick pivots on the top of a block of wood. You have a block of wood in your kit. And this end of the meter stick is held up by the strings going up to the spring scale. Make sure the spring scale is zeroed and do not overload it. There's another paper clip up here going to a clamp on top of the door. Before you build this truss, make sure to weigh the object that you're hanging and weigh the meter stick separately by the spring scale. The goal of this lab is if you know those weights, you should be able to predict what the spring scale reads. In order to do the calculation, you're going to have to use your protractor and measure the angle of the string from the horizontal. You have to put the whole of the protractor where the line of the hanging weight and the line of the spring scale string intersect. Consider the binder clip to be the point of our focus. It's not moving, so what do all the forces acting on it add up to? Now it would help to draw a free body diagram for that binder clip. What are the forces acting on it? Well, the easiest one would be the weight. It's pulling down through that paper clip. Well, we're going to assume that paper clip is all attached to the binder clip. What else is acting on that binder clip? Well, we got the string. Strings can't push, they can only pull. Now, what do you think that meter stick has to do to the binder clip? Well, before I show you, you should try to figure that out for yourself. Attempt the free body diagram. Now, building this thing is going to be a little tricky. A little hard for you to do it by yourself. The meter stick is supposed to be horizontal. That means you may have to adjust the height of the block where it pivots on, and you're definitely going to have to play with the strings. As you can see by the different knots I've tied in here. Now everybody's going to have a different angle, and we're going to collect the data and put it on a spreadsheet. From your free body diagram, you do the calculations for how hard that spring scale is pulling, and that would be a theoretical value. And now you're going to look at your spring scale and read it and tell me the experimental value. Have fun.